All right, for this lesson, lesson 9, today we're going to talk about also, again, statistical process control, although this time, and we're going to continue to build control charts. We're going to look at 3 different control charts today, and they're going to be the following. We're going to build an X-bar chart or an average chart for the case where the standard deviation is known. And we're also going to build 2 charts in conjunction with one another. The X-bar chart for the case where standard deviation is unknown. And when the standard deviation is unknown, we're also going to use and build an R chart with R standing for range, where range is an estimate of the standard deviation. So those two charts, the X-bar chart when standard deviation is unknown and R chart will go together. All right, some information from last time, just to continue. Control charts are just one tool that managers use to detect possible inconsistencies due to that special cause variation that we talked about. In other words, and then don't forget, we're using these control charts to help us identify those cases when there are significant outliers, where the likelihood of a measurement occurring outside of 3 standard deviations is very, very small. And so therefore it's not likely to be normal, or normal, if you will, random variation, or white noise. You may hear that term. So it gives management the opportunity to correct those errors that might arise. In the case of our attribute control charts, 2 things. Whenever possible, you should use a P chart rather than a C chart. The P chart is, the statistical properties are a little bit more stable. And when you have the opportunity to use a P chart, you should use the P chart. And then lastly, the lower control limit values for these P charts and C charts are never less than 0. So there may be a case where the actual computation for the lower control limit goes below 0, but because you'll never have a proportion where you're counting things less than 0, you can't count negative outcomes for either the P chart or the C chart. So therefore, the actual realization will never be less than 0. All right, let's continue to look at our review the process of what we're doing. This will happen again, in this case, just as it did last time. Management takes a random sample from whatever the process is, and then based on those sample values, compute the center line, which is almost always the average of the sample. There are some cases where that might not be the case, but in this, the situations that we'll look at, it's the average. Then you'll want to compute the upper and lower control limits, which is the center line plus or minus 3 standard deviations. And as you'll see, we will use various values to estimate the standard deviation, as we did last time, and we continue to do today. And then we'll create the control chart. And in the control chart, we're going to plot our horizontal lines, our 3 horizontal lines, our center line, upper and lower control limit, and then the random sample values that will appear on that control chart. And then finally, we're going to examine the control chart. And for our situation, we're just going to make a visual judgment about whether or not the process is in control or not in control. And if the process is not in control, then if we were in an actual situation, we would take these following 2 steps. We would work to identify the special cause variation that caused the process to be out of control or not in control, and would make the necessary corrections or management changes to the operating process to bring it back into control. Our next slide is an example of a process. And so you should look at this and ask as example of a P chart, as you can see, because our center line is a P value, and then our upper control limit and lower control limits are plotted horizontally, and then the sample values. So you should ask yourself, is the process in control or not in control? And if it's in control, why is it in control? And if it's not in control, why is it not in control? You should be able to answer those questions, and give you a second or two to evaluate that and determine what you think that's the case is. Well, in this case, hopefully you've been able to determine that the process is not in control. And there's really three reasons. First of all, you have an observation that's below the lower control limit. And let me do this a little bit differently. You have an observation that's observation number 2 that's below the lower control limit. You have an observation over here that's it's number 19, that's above the upper control limit. And then we also have a situation where it appears that the process has a linear component to it, where it's increasing from left to right. And if this sample is taken over time, if the sample is early in the morning or late in the morning, or if the first sample is the first day of the month and day 20 is the last operating day of the month, then there's something going on in that process related to that time, or this the way the sample was taken. So for this is not in control. And we're going to look at some other examples. And you should look at these in, of course, the explanation tells you what's going on. But none of these are in control. So here's a situation where all but one of the observations are below the center line. And here's a situation where almost all of the observations are above the center line. And here, even though all of the observations actually in all 4 of these fall between the upper and lower control limit, this plot, this control chart, again has that increasing linear pattern, and this control chart has a decreasing linear pattern to it. So in all cases, these charts are not in control for those various reasons. So anytime there's a pattern in that plot, the chart, the control chart is not in control, and there's a reason to investigate. One other thing I want to point out as we go forward, we want to make sure that we are able to, and I apologize for this slide being, I don't know why that is there like that, but we want to differentiate between the sample size, and the sample size is always indicated by the variable n, and the number of samples, and that's always indicated by the letter K. And the sample size is the number of samples that's chosen, selected at each replication. And then the number of samples is how many replications were taken. So in this case, sample number 1 consisted of 5 samples. Sample number 2 consisted of 5 samples, and so forth. And we had 10 samples of size 5. So a total of 50 samples, but there were 10 samples of size 5. Generally speaking, almost always the data is organized in rows and columns. And usually the columns correspond to the number of samples, and the number of rows is the number of samples, and the number of columns is the sample size. But be sure to read the problem statement carefully so you'll know which is which. That'll become important as we go into our examples here. Right now, I want to pause the presentation, and I want to show an example in Excel, and we're going to work I'm going to work an example for you in Excel. And these two examples are going to be the Goliath Tool Company. And you find this first example beginning on page 119 of your textbook. And what I'll do is I'll read that briefly, and then we'll talk through, and then we'll work this example, the Goliath Tool Company. Let me expand this spreadsheet just a little bit for you. There we go. That'll be enough to get us going, I think. Okay, here's the Goliath Tool Company. The Goliath Tool Company, and again, this is page 119, produces slip ring bearings which look like flat donuts or washers. They fit around shafts, rods, such as drive shafts, in machinery or motors. In an early stage in the production process, the outside diameter of the bearing is measured. Employees have taken 10 samples during a 10-day period of 5 slip bearings and measured the diameter of the bearings. The individual observations from each sample are as follows. And what this table shows you, this is the same table that's in your textbook. As we mentioned, sample 1 has 5 samples, all the way through sample 10 has 5 samples. In this case, from past historical data, it's known that the process standard deviation is 0.08. The company wants to develop a 3 sigma control chart to monitor this process. So now our task is to build the control chart. So the first thing you need to ask yourself is, what type of data is this? Is it attribute data or variable data? Attribute or variable? And if you remember, attribute data is counting data, and variable data is data that's based on measurements on the real number line. And in case, if you didn't pick that up, at least twice the word measure or measurement was mentioned in the problem description. So right away, this should tell you that this is variable data. And so we'll need either an R chart or an X bar chart. And then the next thing is, since it's variable data, you're told that the process standard deviation, which we know, we're going to enter it in this, I'm just going to enter it in this cell, is 0.08. That's the process standard deviation, and it's known. All right, now, for each one of these samples, the first thing, and we're going to, since we know the standard deviation, we're going to construct an X bar chart. We don't need to construct the R chart since we know this standard deviation. So the first thing that we're going to do, we're going to compute the average for each one of these observations in sample number 1. In the average, we're going to use Excel to compute the average of these 5 cells. You can see that's 4.98. Of course, you could compute average adding up those cells. I'm doing this in the next row, and dividing by 5. Either way is perfectly fine, but I'm going to use the average function. And because we're in Excel, we only need to type this in once. And then on this indicator in this lower right corner, when that little plus sign appears, we click and we drag that formula down, and all of a sudden we have the average for each one of those 10 samples that goes from 4.98 to 5.03. And these become the values that we're going to use eventually in our control chart over here that we're gonna plot. Okay, those are all of our X bar values. All right, to compute the center line, we're going to compute the overall average of all 10 of these values. And so we call this X double bar, which is the average of the averages. And so again, we're going to use the average function equals average, and then highlight the cells here in column H, those 10 cells, close the parentheses. And then we know that 5.01 is that overall average. Right, the next thing that we need to know is what is the sample size? And what is the sample size? And based on what we talked about previously, we have 10 samples, and each time we take a sample, we took 5 values. So our sample size is 5, the number of samples is 10. Our Z value, which was given to you, is 3. Now we need to compute our sample standard deviation. And the sample standard deviation is going to be part of this formula here, which is the second part of it's this known standard deviation divided by the square root of n. And so for this sample standard deviation, that's going to be the known standard deviation, which is the value in this cell, 0.08, divided by then the square root in Excel, SQRT, of the sample size, which is 5. And so 0.0358 is the sample standard deviation. And now using these values, I'm going to compute in this cell rather than do it separately. I'm going to compute that value of the UCL, which is going to correspond to this formula right above it. So this is going to be equal to our X double bar, 5.01, which is in cell H16, plus our Z value, 3, times our sample standard deviation. And that's 5.12. And then what I'm going to do is in this cell, I'm going to say what goes in this cell is exactly what's in the cell above it. And our center line, we've already computed that. We know that that's this value of 5.01. And the lower control limit, it's going to be equal to our X double bar, in this case minus 3 times our sample standard deviation, 4.90. The value in this cell, we're drawing a straight line, is the value above it. And then the same thing for this cell. And now we can highlight all 3 of these cells, get our indicator, drag those down, And now we've got all of the values. Copied one too many. I'm going to edit, clear all. I don't want that to have any value. And so now I'm going to build the control chart, which is very straightforward. I'm going to highlight these cell values. Again, go to the insert function. Let me scroll back a little bit. We're going to insert. Oh, that's not moving over. We're going to go, let me see if I can, we're going to insert. And then here, you'll see I'm going to choose a line chart, which is this here in the middle. And I'm going to take the very first line chart that pops up. And then here's our control chart. So the question you should ask yourself is this in control or not in control? And then if we were in class, we would have a good discussion. How many do you think it's in control or not in control? If it's in control, why is it in control? And if it's not in control, why is it not in control? And this is an interesting chart because, to be honest with you, without any other statistical tests and without knowing any more about the processes, you could argue that this was either way. You can either argue that it's in control because all of the values are near the center line, about as many above and below the center line. And so you could argue that it's in control. You could also argue that it's not in control because it appears that plots values 1 through 6 possibly, or at least 5, are below the center line, whereas the last 5 appear above the center line. And so you could argue that it's not in control or it needs investigation because there's a pattern. And if these were collected over time, as it's collected during a 10-day period, but you don't know which 10 days, you could actually argue that it's either in control or out of control. And so on an exam or a quiz or whatever, if you have a situation like this and you make an argument, you choose one, and but it's a reasonable argument, then that you'll receive credit for that. So don't worry about, am I right or wrong? Make a good decision based on what you see and describe what you see, and that's the important thing. So this is a control chart in the case where is known X-bar chart. Let me that's the case where the X-bar chart is in the standard deviation is known. And again, I'll leave this, put this on D2L so that you can see it and play with it. Okay. Let's look at the next case. And this is the case where the standard deviation is not known. And this is on page 120 and 121 of your textbook. It's also the Goliath Tool Company. And in this case, the data that we've collected is the same. But however, in this case, the standard deviation is not known. And you'll see that what I've done here, I've already calculated the averages because it is still a variable control chart. and we need to compute an X bar chart. And in this case, and we need to compute bar chart. And again, as you remember, R chart is R stands in this case for the range. And so we're going to compute in these tan cells, we're going to compute our range. And how do you, if maybe you remember how a range is computed. And the range is always going to be maximum value of these 5 cells. It's always the largest minus the smallest, or the minimum of in those 5 cells. And I strongly recommend that you use this Excel function, because if you try to do this by eye, you may get it right, but your chances of making an error are large, because of the large number of data points. And so that's our range for sample number 1 is 0.08. And since we've got this all done, we're going to drag that formula down, and all of those are the ranges for our 10 samples. And then we're going to calculate the average range. So we're going to again use the average function of all 10 of these values, and that's 0.12. So now we have all the information that we need to be able to calculate, and I'm going to save here quickly, that we need to calculate our X bar chart and R chart, excuse me. Again, our sample size, we're taking 5 samples, and we do that 10 times. Now, in order to calculate for our X bar chart, the upper control limit, there's a formula that we need to use, and it's the X double bar plus this value A2 R bar. The lower control limit is the value A2 R bar. And A2, I'm going to go to another tab here. A2 is in this table here. A2 serves as an estimate of, given that we're using the range, it's an estimate of 3 standard deviations away from the mean using the range as our statistical estimator. And again, in a higher level statistics class, we would go through and derive this and see where this comes from. But now we're taking it at face value. The thing that I do want you to notice is it's based on the sample size. So you do something in insert column. I know that's, there we go. So this table is based on the sample size. And so we know from the work that we've done previously that the sample size for this particular control chart is 5. And so our value for A2 is 0.58. It's not 0.31. So again, this is where we need to be sure to differentiate the number of samples from the sample size. And again, in our case, the sample size is 5. The value of A2 is 0.58. And so we're going to use that in our computations, 0.58. And then we're going to calculate in this cell the value of the upper control limit, which is 5.01 plus A2 times R bar. It's this value, which is our center line, plus our value of A2 times our value of R bar. And I'm going to use this, and I'm going to reduce the number of to 2 decimal points. And then we're going to compute the lower control limit, which is that center line minus A2 times R bar, and reduce to 5.08 and 4.94. Now for our X bar chart, again, we're going to take these values, our X bar values, which is our sample values, just like we did before, and then the upper control limit is 5.08. The center line is 5.01. The lower control limit is 4.94. And then in this cell, we want to copy exactly what's above it. In this cell, we want to copy exactly what's above it. And in this cell, we want to copy exactly what's above it. Enter, and highlight that. And now we've got all the data. We're ready to build our control chart. We highlight, and you want to highlight the, let me do something here that I wouldn't want you to do, but if you go in and you happen to highlight the sample number and then try to build this control chart, I'll show you what it looks like. Uh-oh, what's wrong here? Well, what's wrong is you've plotted as one of your X values the numbers 1 through 10, okay, which is not what we want. So that's not, I'm going to delete this control chart. So we only want to select and highlight these values of our data: X bar, upper control limit, center line, and lower control limit, and along with their titles. In fact, you don't have to do that. You don't have to select their titles. You could just select the values and then insert your line chart, and it looks like this. You'll notice it doesn't have the labels that you might want. So let me delete this control chart and go back and collect the labels. And now if we build our control chart, it tells you what everything is, and here's our X bar chart. Let me delete this. I accidentally dragged the data indicator over one. Okay, I want to move this up so we can see it. And again, you want to ask yourself the question: is this in control or not? And I would tell you again right away, you can see that this one certainly is not in control, because we have an example 0.9 that's above our upper control limit. And if we go back and look at our data, here's number 9, and it appears that it's right on it. But I know if we had decimal points, you would see that 5.08, which is the average, is just slightly above 5.077. So it is above, and it would cause your X bar chart to be out of control. All right. So let's look. Last control chart that we're going to look at is the R chart. And again, we're going to have the same process. We're going to plot. We've already computed our center line, which is 0.012. We're going to compute our upper and lower control limits. And in this case, our data is our range data, since it's an R chart. So it starts at 0.08 and it runs through 0.10 for sample number 10. Our upper control limit now is the formula that's here. It's D4 times R bar. D4 times R bar. And where do we get D4? Well, we're going to go back to our chart factors. And based on our sample size, we're going to look across, and the factor for D3 for sample size of 5 is 0. And the factor for D4 for a sample size of 5 is 2.11. Again, it's not based on the number of samples. It's based on the sample size. So D3 is 0, D4 is 2.11. So D3 is 0, that one's easy, and D4 is 2.11. So our upper control limit is R bar times D4, or D4 times R bar. And again, I'm going to reduce that down to 2 decimal places. And our lower control limit is R bar times D3, which is going to be 0. So our lower control limit is 0. Our upper control limit is 0.24. And we want this value to be a straight line. It has to be exactly the value above it. And similarly, for this to be a straight line, it has to be exactly the value above it. And also for this, for our lower control limit. And now we're going to highlight those cells, drag that formula down, and we're ready to build our control chart just as we've done before. Insert the first line chart, and boom, there's our R chart. And again, ask yourself the question, is this chart in control or not in control? And hopefully you would answer it is in control. The observations are near the center line, almost as many above or below, and no apparent obvious pattern. So this, let me label this one. This is the X standard deviation known. So there we have it. These are the last 2 control chart types that you'll see. And I'll post this. You have this available to use for your quiz that you'll have. And as always, let me, at this point, let me go. There's a couple more slides that I need to get to quickly. Again, here, this is the table we were just looking at for the factors for the control limits, and it's on page 120 in your textbook. These are the formulas for the 3 control charts for variables. And remember, we are interested in identifying the sample size for the values of A2, D3, and D4 in that table. And then as a review, quick review, these are the formulas for the P chart and C chart. So in terms of solving your problems, how is the data collected? What type of data is it? Is it attribute data or is it variable data? Is it counting data, which is an attribute, or is it measurement data, which is typically or your variable data? So that concludes this lesson, and please let me know if you have questions. I'm happy to assist.